Morning, Kamil.
Morning, Doktor.
Morning.
Sorry.
Okay. Kami tu ke lupa ke Kamil?
Yes,
Okay, tak
betul.
apa.
Baru beli.
Sebab tu tadi I started a little bit with Sugi dah lah, just but maybe cause since kami ada kat sini, we'll just cakap lagi sekali je lah. Okay, to introduce myself, I'm Kelly, so I'll be teaching you guys reaction engineering. Macam saya beritahu kami, macam saya beritahu Sugi tadi, I really understand you guys punya schedule because you are busy with work, so that's the priority. So yang penting is just that as I told Sugi, like for that week, usually I need about 2 hours lecture, 2 hours tutorial lah. We don't necessarily have to follow the schedule. Okay, so just that kalau minggu tu, because I think got 3 of you, you guys discuss je lah what time or what day, what time you want to do the class for the week yang boleh fit kepada kamu bertiga lah. I can fit easily sebab I'm very quite flexible. So for that week, you can have the time, okay, just inform me, then we will do the class. But let's say minggu tu memang tak boleh jumpa langsung masa. I don't mind, weekend ke, malam ke, I'm very okay. Just that kalau minggu tu memang tak boleh jumpa time yang semua okay, sebab I think some of you will be working shift. Just inform me. So what I do, maybe that week we won't have any face-to-face class. I will just put the video lah sebab I'm also teaching the normal students punya class juga for reaction. So I have you guys, I have also the normal class. So for that week, kalau macam we cannot do class, I will just leave the video on the Teams. In the lecture note pun sebenarnya sudah ada dalam Teams ni. So I will just put the video so you guys just watch it lah on your own time. So konsep dia, class is very flexible. It's really depending on you guys to decide. Just that salah satu cabaran utama dia semester ni dah 14 minggu. So that's the biggest challenge. To finish the course in 14 weeks is actually quite challenging lah. So tu cabaran utama. Tapi don't worry, I will try to make it so that is we can accommodate each other lah for the course. Yang penting, you guys should know, I'm very flexible, so don't worry. Kalau apa-apa pun just contact me. We can talk and arrange accordingly. Okay, so kebetulan saya pun baru nak start briefing for the course, so just in time lah Kamil pun masuk dalam meeting ni. Right, so for course, this course is Reaction Engineering, CKB 20104. So I think kalau if you realize the program structure, there are not many courses of 4 credits. Probably one is CPP, which you have taken in semester 2, and this one, the other courses with 4 credit hours, Reaction Engineering. So probably you wonder why. So you guys are in the industry, you guys definitely knows wherever we're talking about producing chemicals, definitely we're talking about producing it through reaction. Okay, so we always have, most of the time, chemicals are produced through a certain type of reaction. Okay, so reaction. Okay, reaction engineering adalah basically the engineering part of the reaction. Meaning, let's say now you have established this one type of reaction to produce the desired chemicals that you want. So let's say you want to produce ammonia. Okay, so the common process produce ammonia is Haber-Bosch process where you react nitrogen gas dengan hydrogen gas. Okay, so the reaction has been established in the laboratory by a chemist. So as an engineer or as a technologist, your role will be how you're going to design and engineer the reaction until you get it in a real chemical plant. And usually reactions will take place in a vessel or equipment we call reactor. Okay, so kalau you guys pergi tengok chemical plant, reactors are basically the heart of any chemical plant because the reactors are where chemical reactions takes place. And usually kalau you go to chemical plant, reactors are the one where the biggest investment will be done by the company, where the biggest study, most of the study will be done on the reactor because optimized reactor, a high performance reactor will give you high conversion, high production rate, banyak produk. High production rate will give you high production, a lot of product of your desired product. Okay, so that's what we're going to do for the next 14 weeks. We're going to learn how to design reactors. So maybe you also wonder why do we need sampai 4 credit hours? Because reactions itself are very diverse. Reaction, even if you change one parameter or one entity in the reaction, the design of reactors will change or will be different significantly. Example, let's say you change raw material. Let's say you try different temperature or different pressure, or you want to use open system, continuous system. Any changes in the reaction will affect the design of your reactor. And then sometimes certain reaction needs to use catalyst. Okay, certain reaction, if the reaction doesn't give you high conversion or high production rate, we will then use catalyst. So catalyst also will influence the design of your reactor. So for the next 14 weeks, basically, we will learn how to design reactors, but it is not so straightforward because, as I said, the change of the reaction, the change of parameters, as well as we have many types of reactor that we will need to learn. Okay, but I will cover just the main ones. Okay, we will cover the open system, closed system, the main reactors, and then a little bit on catalytic reactors, of which you will learn how to design. Okay, so kalau reaction tu chemistry, reaction engineering is a combination of chemistry and mathematics. So basically untuk 14 minggu ni tak banyak membaca pun. Membaca probably like 2 chapters, but the remaining 6 chapters are all calculation, and the calculation can be a little bit tough. To be honest, I also admit calculation to reaction ni can be a little bit tough sebab you will learn how to derive equations sebab it's impossible for you to memorize the equation. So we will learn how to derive the equation, and then we will use this equation to actually design the reactors. Okay, so that's the overall picture of reaction. Okay, my background in degree and masters is in chemical engineering, and in fact, my PhD, okay, I did my PhD in Japan. My PhD is actually in mechanical engineering, and my PhD is really purely on chemical reactor design. Okay, so that's why I think they asked me to teach reaction because and my masters also actually I was doing on reaction as well. So the challenge will be untuk reaction ni adalah sebenarnya dia tak susah if the student really understands the calculation or the design step. It only become a challenge katakan if the understanding tu is not so strong, then it will be a little bit problem. And then second challenge, the chapters are interrelated to one another, meaning in order for you to design a reactor, it has to go through several process. And dalam subjek ni, several process tu dipecahkan mengikut chapter. Meaning, chapter pertama, you have to understand part A. Okay, you go to chapter 2, you understand part B. So chapter 3, you will have to understand, you have to use what you learn in chapter 8, chapter 1, chapter 2 to do chapter 3. So it's a process lah, dah faham proses A, proses B, proses C. Chapter 4, combine lagi all this knowledge, tambah lagi satu proses. Baru pergi kepada chapter 5 dan sampai chapter 6. So the challenge is, katakan kalau student tertinggal satu chapter ataupun student tak faham satu chapter, it become a challenge sebab the next chapter tu dah ke proses yang seterusnya. So kalau tak faham perjalanan pengiraan tu, it become a little bit of a challenge. But no worries, I will try my best. I've been teaching reaction since very long. I've been teaching. I entered Uni KL 2009. Then I taught 1 year reaction. Then I left. I did my PhD. I came back 2013. Since then, I've been teaching reaction for every semester. So I've been teaching a lot of semesters lah. But of course, I will always upgrade the notes. I will always upgrade the information, the knowledge, so that you are aware of the latest technologies in reactor. And in fact, reactor design, reaction engineering is very fast evolving. And like I said, chemical plants always invest a lot of money in the development and improvement and optimizations of chemical reactors. Because you have good reactors, optimized reactor, you will have high production rate, and then definitely that will contribute lah to the income. Okay, so the details of the notes and also video akan ada dalam tip ni. Normally what I do is the video is recorded. I will then edit the video. Okay, I will edit the video accordingly. So it will be then I will upload it on YouTube so that it's easier for you to see. Sebab if you download the video, it will take a lot of memory. So after this class, I will upload on YouTube. I will share the link. So you can always go to YouTube and check back the link for the class. Okay, so that's one way to help you. Lecture notes is also in the Teams, so that you can always refer to the lecture notes as well. Okay, so in fact today lecture note pun sudah ada dalam Teams, right? For information about classes and so on, we already have a WhatsApp group. So anything lah, just for the week, kamu dah bincang kelas pada bila kamu nak buat kelas bersama-sama, you just inform me in our WhatsApp group, and then we can meet for the class, right? Okay, so besides Teams, I also have a VLE, tapi VLE ni bercampur lah Flexilearn dengan normal student, tapi basically semua benda pun sama sahaja. It's actually basically the same thing. Regardless you check on VLE, you check on Teams, it's the same thing. But if you want to have, kalau takut kamu confused, you just check on Teams will do lah. All the information will be on Teams. Submission of assignment, everything will be on VLE, so you don't need to send anything physical. Everything is on VLE. I will then open up lah the submission when the time comes for you to submit your assignment, so on and so forth, right? Okay. So about the class, I think this one kita dah tahulah, tapi as I said before, the classes are upon arrangement of the students, and then we will discuss accordingly for the class. Tapi tak boleh jugalah tak ada kelas tu kena buat, especially 14 minggu memang we can't afford to miss that much of classes. So kalau minggu tu memang tak boleh buat kelas, I will leave the video, but make sure you tengoklah the video for the lesson for the class. And of course, if you have any questions, I'm always on WhatsApp, I'm always on call. If you want, you can call me, or if you're a little bit shy, you can just text me and I will answer accordingly. Okay, so allow me to introduce a little bit on the course. Okay, so syllabus and course learning plan is on VLE, but later I will also upload on the Teams for you to refer. But in essence, basically reaction engineering, we will have 8 chapters. Okay, we will cover everything that you will need to know for the basic design of the reactor, including a little bit on catalytic reactor. So catalytic reactor ni, I would not be able to cover comprehensively in this reaction engineering, because catalytic reactors are in fact another course of its own. So normally kalau because reaction engineering is only 4 credits, normally in some institutes, okay, they even have reaction engineering 1, reaction engineering 2, sebab reaction engineering 2 yang akan cover on catalytic reactors. Catalytic reactors are very complex, so I will not be able to cover in this course, but I will give you a basic understanding so that you're aware what are the actually catalytic reactors and why it is different from the normal types of reactors. Okay, right. So to explain reaction and to explain reaction engineering. Okay, so I always use this introduction for you to understand the normal terms that we normally use in reaction first, and then we talk about reaction engineering. Okay, so let's say a very simple domestic process, domestic reaction that you probably are very aware is about baking a cake. Okay, so when you bake a cake, okay, definitely you will have raw materials, or we call it in reaction as reactant. So reactants are the compound that will react to produce product. So reactant is before reaction, products are after reaction has taken place. So of course, in baking a cake, you have the normal reactant, the normal raw materials such as eggs, flour, sugar, butter, so on and so forth. So these are what we call as reactant, or we call it sometimes raw material. Okay. Then after reaction has taken place, you will get a product, in this case a cake. Okay, so how do we actually know a reaction has taken place? Maksudnya, if you put in raw material, how sure are you a reaction has taken place? So a very basic understanding, we can conclude or we can verify a reaction has taken place if you obtain a new compound after the process has ended. Meaning you put in raw material, okay, you leave it in the reactor. After a certain time, when you take out and you see a new product is formed, that means you can verify a reaction has taken place. But if, let's say, you put in your raw material into your reactor, after a certain time, you take out, you realize that there's no new compound formed. It's still the same original compound, hence you can conclude no reaction has taken place. So that's a very basic understanding, explanation, macam mana kita nak verify a reaction has taken place. Okay, that's one. Now, talking about reactor. So in the case of baking a cake, an oven, the oven is essentially a reactor because the oven is where the reaction takes place. So that's the definition of a reactor. A reactor is where, or a vessel or equipment where a reaction will take place indeed. Okay. So perhaps you think, okay, just a vessel, how complex a vessel can be. But you must understand the reactor must be designed to accommodate the requirement of the reaction. For example, in this case, in order to bake a cake, the oven or the reactor has to be at least fulfill the requirement of the reaction. Baking a cake, you need at least 180 Celsius. Okay, so means the oven must be able to heat up, the reactor must be able to heat up until the desired temperature, which is 180. Next, reaction are very diverse. Certain reactions are very rapid, certain reactions are very slow. Normally, in terms of baking a cake, you will take about maybe 20 to 30 minutes. So meaning your reactor must be able to heat up to 180 or more and sustain the heat for at least 20 to 30 minutes. So that's another thing. Third, let's talk about the distribution of heat in the reactor. Because you know, to bake a cake, the heat distribution must be evenly distributed. Baru tindak balas can be uniform. Baru your cake can be evenly baked. Or else you will have maybe top cooked, the bottom is not cooked if the heat are not evenly distributed. So the design of the reactor, the design of the oven has to also ensure that the heat will be evenly distributed around the whole equipment, the whole vessel, to ensure the cake are evenly baked. Not only that, they also have to consider the configuration of your loyang. Untuk bakar cake tu you need a loyang, right? So the thickness, the depth of the loyang, the size of the dimension of the loyang also plays a part. If it's too thick, perhaps the heat will not be able to penetrate and ensure the cake means the reaction will take place evenly throughout the entire cake as well. So even the design of that thing will also be taken into consideration when we're talking about designing a reactor, designing an oven, which is actually a reactor. So you can see there are many things that you have to consider when we're talking about the design of a reactor. Is as easy as designing an oven for baking a cake. Right. So that is a domestic example. In terms of industrial example, of course, the production of ammonia. Okay, so you're talking about production of ammonia. You know the ammonia is very valuable because ammonia is used in fertilizer. Okay, so we are using fertilizer for food. Okay, so meaning it's a very integral process. It's an integral compound that is used for fertilizer for the sustainability of food in the world globally. Okay, so previously, okay, they found out that ammonia can be produced from nitrogen gas and hydrogen gas. Okay, so this reaction is called as a Haber-Bosch reaction. Okay, so the uniqueness of this reaction, because of this reaction, this two person, Haber-Bosch is actually the two person that found this reaction. So it's Sir Haber, Sir Bosch. They found that, okay, if you react nitrogen gas and hydrogen gas, you can get ammonia. Okay, but the good thing about this reaction is because nitrogen gas is abundant in the atmosphere. Kan sebab atmosphere kita 79% is nitrogen, readily available. So means salah satu reactant tu dah readily available. 79% kat air adalah nitrogen gas. But they found out, okay, when they have a reactor, they mix nitrogen gas and hydrogen gas at room temperature, it will not produce ammonia. Okay, but they find that kalau saya naikkan suhu, I increase the temperature to above 500 Celsius and I increase the pressure as well. I have to have, it's a very high pressure reaction. Found out that these two, high pressure, high temperature, I can actually get ammonia. So they patented the process and they won a Nobel Prize for this process because they have found a process to produce fertilizer from using a very simple free compound in the air, which is nitrogen gas. So they found this reaction and then it comes to the next technology where they design the reactor. So this is where chemical engineer or chemical engineer, mechanical engineer, electrical engineer will work together where they design a reactor of which the reaction has taken place. Sebab tu, they always say in a chemical plant, reactor is the heart of any kind of chemical processing because the rest of the equipment macam separation, macam mixer is basically to facilitate the reaction, you know. But without the reactor of which the reaction takes place, you will not be able to obtain the desired product that you want, which is ammonia. Okay, so that's probably explain kenapa crucially this particular course will be a 4 credit hour course. Okay, so in this course, okay, I keep talking about designing reactor, right? But it's not as simple as, okay, saya nak bina reactor ni, saya nak bina silinder, saya nak letak heater. It's not as easy as that. There are many considerations that you have to taken care of before you can go about in determining how the reactors are designed, because you have to first quantify the reaction. Okay, itu yang jadi masalah dia. Sebab sebelum ni, we always talk about reaction. You know, chemists will always talk about reaction. Okay, but to design a reactor, you must first learn how to quantify a reaction. Okay, apa maksud saya quantify ni? Okay, I can give you a very simple example. The difference between chemistry and chemical engineering. Okay, if you're talking about hot water, okay, kita cakap air panas kan? Okay, so chemistry wise, they will say that why a water feel, when you're holding a cup of water, a cup of hot water, you will feel it's hot because of course the water has been supplied by heat, by energy. So the temperature increase, you will feel the hotness of the water. So that's chemistry. Chemical engineering is about quantifying, right? Kita quantifying benda yang kita nampak. So reaction engineering says, chemical engineering says, why the water feel hot? Because when you put a thermometer, the water is at 100 Celsius or maybe even more. So the number tell us, I can understand why the water is hot because the thermometer say the water is 100 Celsius. I can understand why the water is not hot because the thermometer says 30. So you can correlate 30 to sejuk, 100 to panas. So that's actually chemical engineering. The same as reaction engineering. Okay, we can say chemistry-wise, a reaction has taken place. Chemical engineering will say this reaction has taken place due to the reaction rate, due to high reaction rate. So high reaction rate itu adalah number. So we are quantifying the reaction in terms of numbers, which then we will use to design the reactor. So that's the challenge part. Sebab, like I told you, kalau you tukar raw material, you tukar temperature, you tukar pressure, you tukar flow rate, you change a slight introduction or a slight changes to the reaction, the quantifying changes, the design of the reactor pun dah berubah. So that will be also my main challenge when I'm teaching. Another one, phase. Fasa juga akan mempengaruhi. So meaning, are you using gas-gas reaction, liquid-gas reaction, solid gas, solid liquid, solid-solid? So even that phase will also affect the design the reactor. So bila saya cakap affect design reactor ni, maksudnya pengiraan tu semua dah berubah. So maksudnya katakan I give you a question and I tell you like first katakan soalan tu saya kata tindak balas ni adalah liquid-liquid reaction. Meaning kamu kedua-dua raw material kamu adalah liquid-liquid. Okay, you calculated, right? I can just change the question by saying, how does now the calculation change if one of the raw material is gas? So calculation dia jadi entirely berubah sebabkan if I change the phase of your raw material. So that is actually the challenge of this course in a gist. How do we understand the design changes because of the changes of the reaction? Okay, so that's why in this slide you can see we have 8 chapters. So setiap chapters tu you will need to understand is a building chapter of which chapter 1 kena faham to go to chapter 2, chapter 2 kena faham to go to chapter 3, so on and so forth. Okay, so that's my challenge lah as a lecturer to make sure that you understand this course. Okay, so then I will go to the assessment, a little bit on the assessment. Okay, so challenge reaction ni, benda yang bagus pasal reaction ni tak banyak sangat assessment sebenarnya. So we only have test. So test, I will do 2 tests. So one test is 10%, 2 tests is 20%. So it's going to be online test lah. Okay, as usual, test pun Flexilearn students, I will always give them the flexibility. You decide when you want to do the test. Once you decide, I will then give you the question. So not a problem on that. Next, we have one mini project. Okay, so this mini project is 20% mini project. Okay, and then we have one laboratory. So laboratory part, another 20%. Okay, so on the laboratory, because you guys are working. Okay. Okay, so because you guys are working, okay, so for the laboratory part, I think I will be doing it online. Okay, what I do is most likely, kalau possible, maybe I will do live. But if it's not possible, I will do, I will run the lab. I will run the lab, I will run the lab and record the video. For you guys to see the video. So it will be not live simulation lah. I will do not live delayed telecast of the lab. Okay, I will record the video on the lab. Okay. Sekejap kenapa ada bunyi Okay, so I will do the record of the video of the lab. Okay, so you guys watch the video, and then I will give you the results, and you will do the report. So right now I only have 2 of you. I'm not sure whether Aizuddin will join the lab, will join the course or not. Okay, so to lessen your burden, I would propose that I will combine you guys with the normal student punya group. Okay, sebab kalau kamu bertiga pun saya rasa macam berat nak buat lab report. And then, so what I'm going to do, even last semester pun sama, Hidayah dengan Aizat, the Flexilearn student, I combine them with the normal student punya group for the lab. Okay, the winning points supaya senanglah kamu nak buat lab report pun senang sebab ada group member yang berlainan. Okay, so I will propose to do the same lah. I will combine you guys with the normal student for the lab report. Okay, to lessen the burden. And yeah, nanti I will tell you who are your group members lah for the lab part. Okay, so next one. Okay, I will explain on the assessment. Part ni lah yang macam I will have to explain clearly. Okay, so first one, we have a mini project. So as I told you, mini project is 20%, and mini project is basically you will design a reactor. Okay, so every group will be given each group will have 4 students, and each group you will be given the type of chemical, the production rate, and also the type of reactor. So means kamu dah diberi jenis chemical apa, production rate dia, and also the type of reactor, and you will design the reactor according to the assigned name lah. Okay, so mini project pun I would like to suggest to combine juga dengan student biasa. Okay, sebab kalau kamu berdua atau kamu bertiga nak buat satu project, it is really very heavy, and I don't think it's necessary nak buat sampai macam tu lah. So I will also combine you with the normal student punya group for you to do the mini project together. Okay, so I think that also will help you lah in the same part, in the same way to lessen the burden on the assessment. Okay, but grouping dia ni tak payah beri kat saya lah, sebab nanti saya akan just beri kamu lah grup mana yang kamu akan dimasukkan lah untuk bekerja dalam grup itu. Okay, one thing that you have to understand, okay, sebab mini project ni dia walaupun dia adalah satu project, although it is one project, but everybody has its own part to do in the project. Meaning normally satu group ni 4 orang, tapi saya rasa bila saya combine kamu dengan group student yang biasa, mungkin akan ada 5 orang dah. Okay, so when you have 5 people, so means setiap student tu akan will only execute their part of the report. So means part student 1, they will complete part student 1. If you are student 2, you will complete part student 2. If you are student 3, you will complete part student 3. You are student 4, you complete part student 4. If you are student 5, you will complete part student 5. Sebelum ni saya allocate 4 je. Tapi saya tengok bila saya combine kamu dengan student biasa, saya rasa group tu akan menjadi 5 orang. Tapi tak apa. I will distribute the job, I will distribute the task evenly supaya everybody will have its own part. So kamu jangan bimbang, although mungkin kamu takut kamu tak kenal ke student yang biasa, it is fine as long as you do your part. You combine the report into one report, you already submit. Okay, so students will be evaluated based on their own part of the task. Meaning kalau kamu student 1, kamu buat part student 1, kamu dah di-evaluated for that part. So you don't have to worry about the other members of the group. Okay, so next thing is, mini project ni I divide into 2 parts. Meaning you have stage 1, stage 2. Okay, kenapa saya buat 2 stage? Sebab the amount of work is actually quite a lot. So I split it out supaya tak naklah nanti akhir semester kamu ada banyak sangat benda, kamu dah jadi kelang kabut. So you submit first stage, okay, so stage 1 is about week 5, but we can further nego bila nak hantar. So I will have stage 1 at week 5, stage 2 week 11. So means when you finish your stage 1, you submit at week 5, you already done about 40% of the mini project. Then lagi baki 60% you will submit at stage 2, so you complete the entire mini project dah lah. Okay, so the guideline nanti saya akan ubah sikit sebab sekarang saya baru teringat dah ada 5 student dalam group. Kalau saya combine kamu dengan student biasa, you will have 5 student in the group. Okay, so I adjust a little bit the assessment supaya you are clear, okay, what you're supposed to do when we have the 5th student in the group. Okay, so that's why I have to remind you a little bit different for my mini project. I have 2 stages, of which first stages will be submitted quite early at week 5. Second stage will be submitted on week 11. Okay, so as I told you, satu report tapi everybody will have its own part. Okay, so this is example of the guideline. Nanti saya ubah sikit sebab saya lupa sekarang ada 5 student. Sebab sebelum ni saya buat untuk 4 student. Tapi saya fikir balik kalau kamu berdua, even kamu bertiga pun saya rasa berat sangat untuk buat satu projek. So better saya combine, jadikan 5 orang dalam satu group. Tapi saya kena pecahkan sikit lah distribution of the work. Okay, so as you can see here clearly, every student ada dia punya assigned task. So the spirit is, kalau everybody buat part dia, you will then get one project. Okay, sebab like I told you kan, design reactor ni ada banyak steps kan, banyak stages kan. So every student akan complete one stage. Of course, you have to communicate jugalah dengan your members lah sebab dia kan proses. So let's say, katakan student 1 dah pilih reaction 1. Okay, one type of reaction. Student tu kenalah ikut juga. Tak bolehlah student tu buat proses dia mengikut tindak balas yang berlainan. Tak boleh lah. Okay, so you have to somewhat coordinate. Tapi you can do it on your own without needing the other person to do it for you, or kalau katakan member kamu tak buat, kamu still boleh buat part kamu juga. Okay, so please wait maybe 1-2 days or maybe on Monday I will update again the guideline untuk accommodate student ke-5 dalam task. Yang penting kamu kena discuss dalam member kamu, are you student number 1, student number 2, student number 3, student number 4 or student number 5 dalam group tu, and then you will then do only your part for the mini project. Okay, so mini project dia, I already give you a very clear guideline sebab my style is I prefer my student to know what they are doing. Supaya kamu tahu, kamu ikut je guideline tu. Katakan kalau task student 1 ni ada 5 benda yang kamu kena buat, kamu buat je. As long as you do, I can promise you can get good marks for reaction. Okay, so that's my hope lah. Saya tak nak bebankan student. Saya dah beritahu apa yang kamu kena buat, kamu buat je. Okay, then you should be not a problem for you to get quite good grades for the course. Okay, so mini project report. Okay, I will then you will just compile. Okay, get your member to compile one report. Okay, so you have to communicate with your members lah, and then submit on VLE. So no need any physical submission, just hantar dalam VLE. So mungkin part kamu hantarlah kepada member kamu, seorang akan compile, submit dalam VLE. Okay, so that's on the submission. Okay, test. We will have 2 tests. So we got 8 chapters, right? So test 1 will cover chapter 1 to 3. Test 2 will cover chapter 4 to 6. So test will be done online lah. So normally my style senang je. My style saya, we will set the time, okay, of which you guys that agree. I will email you the question. I will just email you the question, and after the time is over, you just email me back. Okay, so memang tak payah on camera ke, tak payah go on Teams, no need. I work I function on basis of trust. Means I give you questions, you solve your questions. It's an open book. Okay, question saya untuk during the pandemic time is all open book questions. So means kamu tak payah hafal apa-apa, kamu kena faham je. You have to have understanding. You can refer to notes, you can refer to book, you can refer to anything during the test, and then you just submit back the answer. Even final examination pun right now they are saying it still should be online. Tapi I'm not sure lah. Maybe lepas 14 minggu dia tukar jadi physical, I'm not too sure. But if it's still online, if it's still online assessment, final exam pun saya buat macam tu. Memang previous semester pun saya buat macam tu. Saya just email the question, maybe 30 minutes before the exam start, I email you the question. You just email me back the answer 30 minutes after the exam has ended. Open book. You can refer to any kind of books, any kind of notes, anything for the final exam. Okay, so same concept with test as well. Okay, next one, laboratory. Okay, so I told you before this, by right kena buat physical lab, but the cases are increasing, and I know you guys are busy, and I think it's still okay. No need, we don't need to do physical lab, but I will do live there. I will do demo. Okay, tak payah live. I don't need live. I will just do the demo. I will record the demo, and then you guys refer to the demo, watch the demo to understand the laboratory. I will provide you with the results, and you will do the report. Sama konsep, lab pun saya akan combine you guys dengan student biasa untuk buat lab report. Okay, so that's how I hope you guys understand. That's how I try to assist you in ensuring that you can fulfill the requirement of the course without sacrificing your work. Okay, so lab report pun saya akan combine group yang sama untuk mini project. Means kalau kamu dah join group tu untuk mini project, group tu jugalah untuk lab kamu supaya senang communication. I will give you by next week the details of the grouping. Okay, untuk lab ni a bit not complicated lah, a little bit more assessment sebab by right for lab part in Uni KL we focus on the skill or practical skill. Okay, sebab tu our assessment tak boleh hanya setakat lab report, sebab kalau hanya setakat lab report it doesn't properly reflects your practical skill. However, kalau macam perjalanan lab yang biasa, normally I will give 10% lab report sebab 20% marks kan. I will just allocate 10% for lab report, another 10% tu untuk practical skill. Tapi sebab sekarang kita tak boleh buat practical, kita dah buat online. So what do? I still have the same distribution. Lab report tu masih 10%. Okay, meaning kamu hantar lab report, 4 lab report, you already get 10% of your final grade. Another 10% tu I will do what we call as psychomotor dengan pre-laboratory assessment. Okay, this saya akan terangkan apa maksud dia. Okay, another concept juga before I go to that, similar to mini project, for lab pun walaupun you will submit one lab report for each lab, but even in that one lab report, everybody will do its own part. Maksudnya satu lab report tapi setiap orang akan buat part-part dia sendiri, combine untuk menjadi one lab report. Okay, because of that, untuk lab ni unlike mini project, macam mini project kalau kamu student 1, kamu akan buat semua part sebagai student 1. Untuk laboratory ni berlainan. Kamu kena rotate number tu. Maknanya katakan this week kamu student 1. Okay. Maknanya ada 4 lab report kan? Okay. Katakan this week lab report 1 kamu student 1. Okay. So for the second lab report kamu rotate jadi student 2. Okay. For the third lab report kamu rotate jadi student 3. For the next lab report kamu rotate jadi student 4. Okay. Nanti saya akan ubah juga sebab sekarang ada 5 member. I have to change also the assessment for the lab report to ensure every student, 5 student tu akan ada part dia sendiri. Tapi kamu kena ingat, kamu kena rotate number student tu means this week lab report 1, student 1, lab report 2 tu jadi student 2, so on and so forth. Okay, sebab every student will have its own part to do for the lab report. Okay, what do I mean by that? Okay, yang assessment ni saya kena tukar sebab assessment ni untuk part student. Okay, when it's 4 student, I divide into lab report tu jadi 4 parts. So the first part is summary and result, meaning if you're student 1, for that one lab report, for the report let's say lah lab 1, student 1 dia hanya buat summary dengan result je. Okay. Kalau kamu student 2, kamu akan buat discussion. Student 3, you will do conclusion recommendation. Student 4, you will do tutorial. So meaning, kamu nampak, kamu kalau combine dia jadi satu lab report. So dia tak membebankan setiap student. So satu lab report tu dia buat part dia je. Dan the next lab kedua, sekarang student 1 tu akan menjadi student 2 lah. Means untuk minggu yang seterusnya, dia akan buat summary result pula. Dan ada student akan buat pula discussion. Ada student pula akan buat conclusion, so on and so forth. So means every lab tu you will play one role, you will do one part, so that you will then finally combine and get the lab report. So we only have 4 lab report for you to do. Okay, so I will adjust a little bit on the student 5 sebab sekarang ada 5 student to make you tahulah kamu punya distribution of the work. So if you can see, again, I try to make sure you don't have that much of work. Okay, that one is for lab report. Okay, so next is in my practical skill kan, saya kata practical skill ada 2 assessment lagi sebenarnya sebab lab report 10%, another 10% by right practical skill. Okay, so this practical skill I divide lagi 2. Okay, taklah sikit je. The first is on pre-lab assessment. So by right, kalau a real physical lab, the student have to do pre-lab sebelum dia masuk lab. Basically, it's just to understand, to test your understanding sebelum kamu mula lab. Okay. Tapi sekarang sebabkan kamu pun tak masuk lab physical, you still have to do this pre-lab. So you put in your mind, saya buat pre-lab ni sebelum saya start buat lab. Supaya for you to understand how the lab works. Okay, so the pre-lab pun I divide into student. Meaning kalau student 1, katakan minggu tu lab 1, kamu student 1, you will do student 1 punya pre-lab. If that lab you are student 2, you do student 2 punya pre-lab. You are student 3, you will do student 3. You are student 4, you will do student 4. Okay, so means kalau ada 4 lab, kamu akan basically buat setiap lab tu satu pre-lab lah. Kalau minggu lab 1 kamu buat student 1 punya pre-lab, minggu kedua kamu buat student 2 punya pre-lab, minggu ketiga student 3 punya pre-lab, minggu keempat student 4 punya pre-lab, something like that. Okay, so you have to discuss among your members lah who's going to be student 1, student 2, student 3, student 4, and by right ada student 5, which I will then do it accordingly supaya kamu akan tengok siapa tu sebenarnya student 5 dalam lab kamu juga. Okay, so that's on pre-lab. And one more, psychomotor. So barat psychomotor ni, kalau physical lab, I will evaluate you during the lab time. Ini as you conduct experiment, I will evaluate you. Unfortunately, sebab kita tak ada physical lab, you will have to just answer some questions in your VLE. So psychomotor skill tu will be asked through VLE lah. Dah jadi macam bertulis lah. But I will ask you just the normal practical skills that you will do in your lab. By right, pasal safety, a little bit about the experiment. So, because kalau macam lab yang sebenar, saya akan tanya kamu juga. Masa kamu buat lab, I will test you on your knowledge as you are doing the lab. So, instead of asking you face to face, I'll ask you through a quiz. Dia macam quiz lah dalam VLE. But don't worry, okay, I will guide you accordingly when the time comes. So kamu jangan takut, jangan serabut sangat. Memang saya akan inform kamu, okay, hari ni, minggu ni, kamu kena buat psychomotor assessment. So saya buka, saya suruh kamu buat, saya akan bagi kamu link. So I will give you the guidance on the deadline accordingly supaya kamu tak serabut. Sebab saya tahu memang you are taking other courses, memang setiap course ada banyak assessment, memang akan serabut. So I will help you to ensure that kamu tak serabut. Okay, sebab last semester memang dengan Aizat, dengan Hidayah, saya faham memang cabaran lah, memang sangat mencabar. Memang kadang-kadang dengan shift dia lagi, kadang-kadang dengan I'm sure you have family member, you have families as well, you have a lot of other responsibility that can be very taxing on you guys. So I will try my best to assess. Yang penting you guys pass the course, ambil sekali, dah habis, then you can move on to the next course next semester. Okay, alright. So then a little bit on the laboratory before we finish for today. We're about to finish, just a little bit on the laboratory. I will do lah demo juga. I will do demo lah juga selepas ni lah. Okay, so but basically we have 4 experiment. And why we have 4 experiment? We will do experiment on all the types of reactor that you will learn. That's why the first experiment, kita ada batch reactor. Okay, even in the batch reactor, experiment 1, dia terbagi kepada 2. Experiment 1A, experiment 1B. Okay, but you will only do either one lah sebab A and B is two complete experiment with two complete different procedures and different type of discussion and study. So bila saya beri kamu schedule tu, kamu kena tengok kamu nak buat lab report untuk eksperimen 1A ke eksperimen 1B. So make sure you check and you do the correct lab report lah. Okay, so but experiment 1 is on batch reactor. So batch reactor, kalau kamu tengok dalam gambar ni, I think you've heard a lot about batch reactor, right? Batch reactor is a closed system. It's a very simple vessel of which, okay, before the reaction take place, means pada minute 0, you put in your raw material, okay? Then you will close your vessel, closed system, close your vessel, let the reaction takes place, let's say 10 minutes. So from minute 1 to minute 10, you do not disturb the system at all. You just let the reaction takes place. Nothing goes in, nothing goes out. And then after the 10 minutes, let's say minute ke-11, you open your reactor, you take out your product, and you take out your unconverted reactant. So that's a batch reactor, closed system. And batch reactor, you will have a stirrer, a very main configuration of a batch reactor. You will have a stirrer to ensure you will have a stirrer to ensure uniform distribution of heat and concentration, so they are evenly mixed. So that's batch reactor. Okay, if you go to your right hand side, experiment 2, we call it as continuous stir tank reactor, or the abbreviation CSTR. Okay, so daripada perkataan CSTR, kamu dah boleh agak apa itu reactor tu punya function. First, continuous, meaning this reactor is an open system. Okay, apa tu open system? Meaning, throughout the reaction, daripada minit 1 sampai minit 10, the reactant are constantly pumped into the reactor, means the reactant will constantly introduce to the reactor. At the same time, the product and the unconverted reactant are continuously flowing out. So flow in, flow out, flow in, flow out. That's why it's called open system. Okay, that's why you realize dalam the picture on your right hand side, kalau kamu tengok dia ada macam 3 vessel, ada 4 vessel sebenarnya. 2 vessel yang kat sebelah yang besar ni, these 2 vessels are the reactant vessels. So dalam tindak balas ni kita ada 2 reactant, sebab tu ada 2 vessel. Vessel yang kat belakang mungkin kamu tak nampak, tapi ada 2 vessel. At this middle one, you see the slightly small vessel, this is your CSTR sebenarnya. Dan yang kat bawah, yang vessel yang satu yang kat bawah tu, yang tak transparent tu, this is your product tank. Sebab dia continuous kan, so saya kena continuously pump in masuk reactor, daripada reactor tu kena continuously pump out to your product tank. Sebab tu kamu tengok ada 4 tank sebenarnya untuk CSTR. Berbanding kalau dengan batch, you realize batch dia 1 tank je. Sebab sebelum reaction berlaku, I just put in my raw material, put in all my raw material, tutup, tindak balas berlaku, after the reaction takes place, I just take out. That's why there's no additional tank. But CSTR akan ada product tank, ada reactor, ada reactant tank. Okay, then next, stir. Kenapa dia stir? Sebab CSTR macam batch ada stirrer juga. So stirrer is an integral part of reactor because to ensure evenly mixed, okay, evenly mixed in terms of concentration and also in terms of heat. So katakan kamu nak panaskan reactor, the stirrer function to evenly distribute the heat. Sebab kalau heat tak evenly distribute, reaction will not be evenly distributed. The same as concentration. Katakan kamu ada raw material, 2 raw material, if they are not evenly mixed, the reaction will not take place evenly. Okay, so in fact dalam reaction, dalam reactor engineering, the design of the stirrer is in fact a own field. Ada satu field yang hanya kaji design configuration stirrer. Bagaimana bentuk stirrer. Sebab stirrer ada banyak jenis. Kita ada baffle, kita ada we got different type of stirrer, you know. And there are special design companies who only study on the design optimization of the stirrer. Okay. Of course, we're talking about besides the design, the speed as well. Sometimes certain reaction needs vigorous speed. Means stirrer tu kena RPM dia kena laju. Certain reaction, no, not necessarily. So certain reaction you need slow speed. So again, that's also the engineering side that people even study the speed of the stirrer, even the length of the stirrer. Should your stirrer be in the middle at the bottom, at the top, also another study on the length of the stirrer pun boleh menjadi study in the when we're talking about reactor engineering. Okay, so that's on CSTR. Okay, so continuous stir tank reactor. Reactors to signify reactions are taking place in the vessel. Okay, so CSTR pun ada eksperimen A dan B. So experiment 2 will have 2A and 2B. But you will only do report on either one sebab dia mengkaji dua benda yang berlainan. Eksperimen A mengkaji residence time, meaning basically I study the flow rate. Okay, how does the flow rate affects my reaction? Okay, should I use fast flow rate? Should I use slower flow rate? How does this flow rate influence the reaction? Of course, it influence sebab flow rate, kalau flow rate laju, a fast flow rate, meaning a short residence time, kan? Sebab dia mengalir dengan cepat, residence time is short. If slow flow rate or low flow rate, higher residence time. So why does this important? Is because certain reactions are fast, certain reactions are slow. If the reaction are fast, then you just need short residence time, meaning the molecule will just need to stay a little bit, only just a short time the reactor, the reaction has taken place. But certain reactions are slow reaction, meaning kamu kena retain molecules tu dalam reactor untuk jangka masa yang panjang, baru tindak balas tu berlaku. If the residence time are too short, too fast, molekul itu tak sempat bertindak balas, dia dah pump keluar. Sebab dia continuous kan, you pump in, you pump out. So you have to control how long the molecule must stay in the reactor for the reaction to take place. If it's not enough time, the molecule dah flow out, the reaction has not taken place. So that's part A, reaction A, experiment A. Experiment B is temperature. So again, certain reaction needs temperature tu sebenarnya adalah energy, heat. Ya? Temperature, increase heat, actually increase energy. So certain reaction will need additional energy for it to occur. Certain reaction doesn't need the extra energy. So why does this important? Ataupun kenapa ini boleh berlaku? Sebab every reaction we have what we call as activation energy. Nanti kamu akan belajar. Activation energy ni adalah minimum energy the molecule must have before the reaction can take place. Okay, so certain reaction ni, certain reaction ni, activation energy dia tinggi. Maksudnya kamu kena make sure molecule ni ada cukup tenaga tu through heat, baru dia boleh berlaku. So if this kind of reaction, you need to increase temperature. Certain reaction tak payah. If it's a low activation energy, okay, the molecule has sufficient energy dah boleh berlaku. So we have to study how does this affects the reaction. So tak semestinya semua reaction memerlukan suhu yang tinggi. It really depends on the activation energy untuk tindak balas itu. Dan usually, if you're talking about chemical plant, dia akan pilih tindak balas yang activation energy itu rendah sebab mudah berlaku. Kalau saya pilih reaction yang takes a lot of energy, it will also, because energy means heat, means kamu kena tambah heater, there's additional cost. Okay, so there are several factors lah to be considered when we're talking about the design of reactor. Okay, so you will learn this later. Right, next one, the third experiment, plug flow reactor. So plug flow reactor ni lain sikit daripada batch dengan CSTR. Okay, but plug flow reactor is the most commonly used if it's a gas phase reaction. Kalau gas phase normally kita akan guna plug flow reactor. So kalau plug flow reactor ni pun it's an open system. Sebab tu kamu tengok ada 4 tank juga. Ada 4 tank. Kalau dia open system, you will have more than 1 tank. Why? Kalau bottom ni you see the 2 big tank, this is your feed tank. So your 2 raw material punya tank sebab dia akan pump continuously into your PFR. Yang reactor tu sebenarnya yang kamu nampak yang tinggi ni, yang vertical ni. And reactor dia adalah kalau kamu nampak the vessel yang coiling kat dalam tu, yang melingkar kat dalam tu, yang tu sebenarnya kamu punya reactor. So imagine that the two reactant flow in, mix, they will flow through the coil. So dia akan flow, akan go through the coil until at the top will flow out to your product tank yang kat bawah ni. So it's a continuous process. flow in, feed tank flow in from the bottom, go across the PFR, flow out from the top, goes down to the product tank. So it is an open system juga. It is an open system, but it's in the form of a coiling ataupun kita panggil tubular. Betul, dia sebenarnya adalah tube. Tapi kalau tube, kalau kamu perasan, kalau kita nak guna tube yang straight, it will take a lot of space. So I use a straight tube, I bentukkan tube tu jadi jadi coiling untuk jimatkan ruang, space. To save the space, the tubular is in the form of coil. Okay, so but it's still an open process. Okay. Next, that's experiment 3. Okay, experiment 3 pun sama, ada A, ada B, depending on you're studying the effect of residence time or the effect of temperature. Lastly, experiment 4. Okay, experiment 4 is a very different kind of experiment sebab dia, if we're talking about reactor, okay, dia tak semestinya kena guna satu reactor sahaja. Okay, maybe we have an understanding, oh kalau tindak balas tu berlaku, guna je lah satu equipment kan? Not necessarily. Okay, what does this mean? Okay, sometimes after you have undergone reaction in one reactor, kita kena tengok conversion. Okay, conversion berapa banyak raw material kita converted menjadi produk. Okay, simple way nak describe this. Katakan, early on, your raw material, you pump in let's say 100 mole of A. Reactant reactant A, kamu pump in 100 mole reactant A. Let's say after the first reactor, you realize only 50 mole A converted to become product B. Meaning 50 A dah hilang menjadi B, ada lagi baki 50 mole A kan? Okay, so you know in chemical plant, in industry, any unconverted raw material is a waste of money sebab dia adalah, kita nak seboleh-bolehnya all 100 A becomes B. Means all my A akan menjadi produk. But now when come out from the first reactor, I still have 50 mole A and 50 mole B. B yang produk yang saya nak. So what happened to this 50 mole A? Okay. So in a chemical plant, you have two options. Option pertama, you separate dulu. Means you separate out A and B. So you recycle back the A. Okay, raw material memang sentiasa dia akan recover balik sebanyak boleh supaya dia boleh recycle balik dalam proses. So that's one way, kamu kena separate dulu. Meaning you have to have additional separation equipment. It can be whatever it is lah. Untuk separate A dan B, B produk saya dapat, A saya recover, saya recycle balik. Second alternative, rather than saya separate recycle balik, apa yang saya buat? Sebab ni kan continuous system kan, so apa yang keluar daripada reaktor pertama tu 50A, 50 mole B tu, I flow it to the second reactor continuously. Saya sambung kepada reaktor yang kedua, so I have this 50 mole A, 50 mole B with the hope that in the second reactor baki yang 50 mole A ni boleh di-convert menjadi mole B. So means this 50 mole A with the hope will become another 50 mole B. So dapatlah 100 mole B sekarang. So instead of 100 mole A, first reactor 50A, 50B, second reactor 100B. So that's one way. So you connect more than one reactor continuously. We call it in series with the hope that the unconverted reactant will become product. Okay, so in our laboratory, we have this reactor in series. We have 3 CSTR in series. Dia tak semestinya 2 reaktor in series. It can be more than 2. And in our laboratory, we have 3 in series. Means from the first reactor, tindak balas, flow to the second reactor, tindak balas lagi, goes to the third reactor, tindak balas, baru kita recover produk dia. So, kalau kamu tengok, bawah ni ada 2 tank. This is again the feed tank. Flow to the first CSTR, continuously float to the second one, to the third one, baru balik kepada product tank. Then we will do comparison dengan single CSTR and we will do comparison dengan 2 PFR in series. So yang kat belakang kalau kamu nampak 2 yang tinggi tu adalah PFR and these 2 PFR are also continuously bersambung. So kita kaji tindak balas yang sama dalam 3 configuration reactor yang berlainan and we compare the performance. Are this performance better in a single reactor, in a 3-stage reactor or in 2 stage of a PFR, jenis reaktor yang berlainan juga. So that's what we do in experiment 4. Okay, we study the different type of configuration and actually different types of reactor as well. Okay, so that's experiment 4. Right, so that's all to explain on the laboratory, okay, on the experiment. But don't worry, nanti bila nak sampai kepada lab report, probably in week 3 or week 4 lah, I will start on the lab. I will explain more. But as I clarified, you don't need to come for physical lab. I will do the demo. I will give you the video. But kamu kena tengok lah video tu. Nanti kalau kamu tak tengok, mungkin kamu takkan faham. Report, macam nak tulis report tu lah. Okay. Lastly, is on the reference book. Okay. Of course, I will provide you with the notes. And but if you want to have additional information, we have this. We use this Fogler. So this Fogler is the #1 book. In fact, not only in UniKL, not only for my course. In the entire world, if you are chemical engineering students, you are learning reaction, you will use Fogler. Fogler is the most famous book lah, reference book for this. And our UniKL library, UniKL MySet library has the e-book for this. Okay, so I will try to find the link for you guys. If you guys are interested, you can actually download the book for free from our library, using the e-book access. But I will try to find the access. Ada, but I cannot remember dah kat mana lah dia punya access for the e-book. Okay, so this is the additional reference. And that's all lah for today for my class. As I told you, I will start the lecture for chapter 1 next week lah. Just that minta tolong kami dengan Sugi dengan Aizuddin kalau dia ada join kelas ni, to inform me what day you are free for the class. And if kalau possible, saya okay je anytime, malam atau weekend saya okay. But let's do one class, at least one class, so that we can start a little bit on the chapter 1. Okay, so before I finish for today, is there any question ke atau apa-apa ke, ataupun kamu rasa minggu pertama tu dah macam dah berat ke? Ada apa-apa tak daripada Sugi dengan Kamil?
Tak ada, doktor.
Okay, Kamil, okay tak Kamil?
Okay, doktor.
Kami dulu sebelum degree ni kami belajar kat mana kami? Macam kena je muka kami ni. Kami H mindset
Tak, saya dulu UTM Melaka.
Oh, but you look very familiar. Kami tengok muka kami macam rasa macam pernah ajar. Sebab tu saya ingatkan kami daripada mindset dulu. Bukanlah. Kami kerja kat mana sekarang Kamil? Petronas Tengok baju macam Petronas.
Tak, baju ni waktu saya belajar dulu. Sekarang saya baru start kerja Februari, join Victor.
Kami kerja shift ke atau kerja yang tetap office hours yang fix?
For now, office hour. Because sekarang ni tengah construction lagi. Plan baru.
Okay. So kami tak, maknanya kalau kami malam dengan weekend tu okay lagi lah, boleh lagi lah kan?
Yang weekend ni esok sebabkan construction kan dia run 24 hours. Bukan not 24 hours lah, tapi 7 days per week. So sampai Sabtu Ahad tu kalau kita kena ada buat witness ke